All right. Welcome back. That should have been an easy quiz for you to get 2 out of 2 on because there was no correct answer. Therefore, you all just raised your grade by doing that. So we'll talk about that in a little bit. I have several things that I want to do to get going here today. First of all, I added a new link to Blackboard, and you'll see it there. It's called Course Docs and Links, and we'll look at that today in a little bit. Basically, what you're going to find there from now until the end of the semester is that's where I'm going to put all kinds of documents, all kinds of videos, internet links, PowerPoint, you name it. It's any document that I share with you in class or anything like that, it's going to be there. Now, if you go there now, you'll see that there's a ton of stuff there because I just copied it over from what I did last semester, but a lot of that might change as we get going. So there is a PowerPoint on there called Day 2 PowerPoint, and you don't have to open it because I'm just going to go straight to it, and you can follow along on the screen. We're going to do several things today. The first thing I want to show you is the results of your bell work from Wednesday when you did iBlank math, and this is how it turned out. Anybody ever seen a word cloud before? The larger the word, that means the more often people used it. So I was happy to see that the most often used word was like, which is good, right? There's an enjoy, there's love, but you also see a hate and a dislike. Actually, dislike was, I think, the second most popular word. But the fact that the likes beat out the dislikes, the positives beat out the negatives, that's great. So what was ironic as I read through all of your responses, though, is a lot of you said, I like because or I dislike because. And if you were a like or a dislike, your because was the same reason, which is strange. Somebody would say, I really like math because you get to use formulas and you get to plug in numbers and you get to use equations and you can figure things out. And then the next person would say, I hate math because you have to use formulas and you have to use equations and you have to plug in numbers. So everybody has their own feeling about, what math is and what math isn't and what they like about math and what they don't like about math. So I want to talk a little bit about that as we get going. There's a guy named Conrad Wolfram, and him and his brother made this Wolfram Alpha. It's a math software that you might have heard of before. And according to him, there are 4 steps in doing mathematics. All right? You identify a real-world question or problem. Then you put some mathematical model or equation or formula, something that applies to that real-world problem. Then you do the computation. You solve the equation or whatever. You pull out your calculator or whatever. And then once you have the answer that you solved for, you take that answer and you apply it back to the original situation and you see if you solved your problem or not. Okay? The argument that he makes about math education in the United States, however, is that teachers and students spend about 80% of their time on step number 3. And they largely ignore step number 1, step number 2, and step number 4. Okay? So a class that does that would be a class that is like an algebra class, and basically 80% of the time the teacher gives you an equation and they say solve for x. And then you solve for x. Does anybody ever feel like that's what math ends up being? Here's an equation, solve for x. And once you've mastered that one, I'm just going to give you another equation and another equation and another equation. And it's just solve, 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 solve. And some of you alluded to that in your writing because a few of you said, I really like math because I know that there's always one exact answer. Well, when a student says that, what I believe they're referring to is when I'm solving an equation that happens to have exactly one answer, I know that there's exactly one answer and every other answer is wrong. Because sometimes that's the case, right? If I gave you x plus 3 equals 5, how many answers does that have? 1. X equals 2. And anything other than x equals 2 is incorrect. You guys agree? But not everything we do in math always has one exact answer. Sometimes the data is a little messy. Sometimes we have to guess. Sometimes we have to estimate. Sometimes the model that we apply to the situation isn't the most perfect model in the world, but it's the best model for estimating that we have. So 3 or 4 people could solve a problem and get 3 or 4 different answers, and it doesn't mean they're all either right or wrong. They could all be correct in the way that they set it up and the way that they made their estimate. So if you think that everything in math has exactly one answer, I want you to try to shut that thought off from your brain as we work on some of this. That being said, when we start in this class, we are going to do a lot of equation solving at the beginning. And yes, pretty much all of those, there is going to be one correct answer. But we're going to do a lot of things later in the semester that aren't necessarily that way. So what do we do when we're solving? A lot of times we're just told to find x. And I always think of this cartoon because I think it's funny. You guys ever seen that one before? Okay. This is from your syllabus. Math 103 addresses the following VCSU general education outcome: quantitative literacy. Notice the words that are used here: number sense, understanding, problem solving, logical and analytical thinking, and communicate viable arguments. Nowhere in there does it say VCSU wants you to be able to solve equations. It's much, much more than that, right? I often, with my math education students, I cite the math standards for mathematical practice. Go ahead and turn around and look at the posters on the back of the room. If you can read them, standard number 1, I like that one a lot. Make sense of a problem and persevere in solving it. We're going to do a lot of that in this class. I'll give you an open-ended problem. It might come from a video. It might come from a picture that I show you. And you have to say, what's going on there? What's the mathematical model? What's happening? And you're going to make a guess, and you're going to try to figure something out. Okay? You can look at the other ones later if you want, but notice none of them up there say solve equations. It's bigger than solving equations. Here's another thing that I like. I saw this poster in a high school math room about 6-7 years ago when I was visiting one of my student teachers, and I took a picture of it because I very much believe in this poster. Step-by-step logic is more important than memorizing. All right? Now, there's certain things that we do want to memorize, like 6 times 7 is 42. That's a good thing to memorize because we don't want to have to sit and think about it for a while, right? However, if you think you're going to tackle algebra or you're going to tackle math by saying, if I run into this scenario, I need to memorize the procedure and then apply that. But then if I run into this scenario, there's a different procedure that I need to memorize or a different formula that I need to memorize. Pretty soon, the number of scenarios that you run into is countless. We can always come up with new problems. And if you're trying to memorize a procedure or a formula for every single scenario, your brain is going to run out of, you can't memorize that much, right? So even if you're not a good memorizer, step-by-step logic is far more important than memorizing. And I hope I can elicit some of that as we do some problems and problem solving in this class. So the course syllabus, the course description for this class, notice that I highlighted equations and inequalities. We are going to solve equations and inequalities, and we're going to do a lot of that in Chapter 2. But we're going to do mostly, probably the key with what we're going to do in this class is the use of functions. Linear functions, quadratic functions, polynomial functions, logarithmic functions, exponential functions, graphing, looking at the behavior of functions and whatnot. So, you guys just commented on the GeoGebra assignment. How did it go? You should have uploaded it to your shared folder by now, right? Did anybody answer, oh, this is the worst experience of my life. I never want to use GeoGebra again? Honesty? Nobody answered that? Did anybody answer, was it the first one that said, what a great tool? Great? Awesome? Somewhere in between? Okay. We're going to use it a lot. We're going to use it today. So have your laptops ready to go. We're going to practice a few things. If you look at the course schedule, I did add a new column. and that column is learning objectives. I just put it on there like 10 minutes ago. So what are we going to do today? We're going to plot points in GeoGebra. And I'm going to show you a couple different ways to plot points. We're going to graph some lines. We're going to talk about the distance formula, the distance between 2 points. We're going to talk about midpoint. And we're going to practice a little bit of that. So here's what I'd like you to do. Underneath course docs and links, you will see GeoGebra practice data. See that one? It's a spreadsheet. Go ahead and open it. And it'll look like, not this one, it'll look like this. Everybody got it open? And what I'd also like you to do is open a brand new GeoGebra file. Mine just pops up and looks like that. Okay? What you should have learned, and what you should probably already know, is if I want to plot a point on an XY plane, and you guys learned how to do that in 5th and 6th grade, right? X this way, Y this way. In GeoGebra, when we do it, we always go parentheses and like 2, 3 or something like that. Parentheses, X, Y, close parentheses. That's pretty standard algebraic notation. So I could type in that point, I could hit enter, and then it plots the point 2, 3. I'm going to show you a little bit of a shortcut if you ever have lots and lots of points and you don't want to punch them all in. Okay? So what I did on this spreadsheet that I had you open is I gave you a bunch of points. This is 6, 85, 5, 87, 14, 65. See what I'm doing? The A column is the X's, the B column is the Y's. I'm going to show you how you can copy and paste those in if you ever had it in a spreadsheet and you want to plot a bunch of points without typing them all in. So go ahead and highlight all of those numbers in your Excel and hit copy. Once you've copied it, go over to your GeoGebra, and underneath View, you're going to see Spreadsheet as one of the windows that you can pop open. There's a bunch of different windows on GeoGebra. Open Spreadsheet, and it'll pop open on the right-hand side of your screen if you're using a PC. Sometimes Mac pops like different windows open. Is that doing that to you if you have a Mac instead of one window? What I'm going to do is I'm going to click on cell A1 and I'm going to hit Control V, or what do you Mac people do? Command V. And I'm going to paste in, see how I just pasted in my Excel data? If you have any trouble, Oren will help you out. And then what we're going to do, we're done with the Excel sheet now. All we did from that Excel sheet was steal the data from it. Okay? Then what we're going to do is in my GeoGebra, I'm going to highlight all of the numbers again. So column A and column B all the way down to, it looks like there's 21 points. I got it highlighted. I'm going to right click on it, and go create list of points. I'll leave that up there on the screen so you can see it. Create list of points. So what are we doing here? We're plotting 21 points all at one time so we don't have to punch them in individually. 21 wouldn't be so bad, but imagine if you had 80 some. That would be terrible to punch them in individually. It'd be nice if you could just copy and paste it from whatever the source of your data is. So when I create list of points, notice it put them all in there for me. Point A, B, C, D, E, all the way down to whatever the last point is, point U. And then L1 is the list of all of them, list 1. I'm going to close my spreadsheet because I don't need to see that anymore. So somebody tell me why none of my points showed up on my screen. They're too big. They're off the screen. The highest point here is 6, and all these are 98, 82, 71. They're all way up there, right? So once you have your points on here, now I want you to practice sizing your screen so that all your points are visible. Okay? Notice that there was no negative numbers in here at all. None of the X's are negative and none of the Y's are negative. So out of our 4 quadrants, 1, 2, 3, and 4, all of our dots are going to be in quadrant 1, right? So I can put my origin 0, 0. I can put that way the heck down at the bottom left of my screen because I don't need to see any of the other points. So I'm just looking at quadrant 1. So now there's a couple different ways that you can zoom. I could zoom the whole thing in and out, or I could just zoom one axis at a time. And that's what I'm going to do, because my x-axis is already going to 30. And actually the biggest number, I think, was like 20 something. So I don't need all that room on the x-axis. Where do I need my room? I need my room on my y-axis, right? So there's a slick little way of doing this. If you grab your crosshairs, that's your button on the far right. And if you hover over an axis, hover over it until you get that double arrow, and then click and hold, and now you can scrunch or stretch. Notice how just my y-axis is moving, but my x-axis isn't moving at all. Very handy tool. I'm going to scrunch it down. There's my data. 100 is the highest. The lowest looks like point G, like 42 or 43. And now all of my data is on my screen. Okay, I'm going to walk around and see how you're doing. Flag me down if you got lost in any of that, or flag Oren down. You should get a screen that looks a lot like mine. Okay, hover over it till you get the double arrow. You're just missing it. Let's see, it should work. All right. No, come on, Mac. Why is that? No, you got a PC. I can't blame the Mac. Why is that not working? Just jump out of that and jump into it again. If you hover over it. There. See the double arrow? Yep. Hold and now go. Click and hold.
Okay.
By the way, I'm a mouse guy. Like, if I have to run my laptop and I don't have my mouse with me, I'm way slower. So if you guys like using a mouse, using this software with a mouse, for me, is way easier. Anybody having any issues?
It's not letting me do that, but like...
So, okay, I'm gonna close this just so it's not in the way, okay? So, if you just click and hold, you can drag the whole screen. So put that 0, down in the corner. Now, if you go to this guy, you can also do this from that button too. So now, see how yours is kind of scrunched? I would get the double arrow. Oh, come on. Oh, it's different on a Mac. Okay, see how I'm holding and stretching? Because I don't need 120, 140. I don't need to see that. It doesn't really matter. It doesn't change the data. It just gives you a better picture. It's easier to see, right? Does everybody got a picture that is like somewhat easy to see? Like you can see your data, you can see your x-axis, you can see your y-axis. Okay, so why did we do that exercise? So I can show you how to copy and paste a bunch of points in at one time. Now, little contest here. Notice I never labeled the axis. I never told you what any of these numbers are, right? So the x-axis from 0 to whatever G is 22? The x-axis is some variable. I'm going to see if you can figure out what it is. The y-axis goes from the lowest one is point G, and point G was, what's the value of point G, like 43 or 42? 43. So point G is the lowest on 43, and the highest one I think is point Q, which is a 100. Anybody want to take a stab at what the x-axis and the y-axis represent if I were to label it? I'll give you a hint. The y-axis, 100 is perfect. It's as high as you can get. What do you think the y-axis is? It's a grade. Yeah. These are grades from my college algebra students last semester. Okay? Somebody got 100% in my college algebra. That's final grade. Okay? Somebody got a 43%. Final grade. Okay? So this is grade. We okay with that? What do you think this is? It's not the number of students. The number of students is the number of points. Each point represents one student. So for example, this student got an 82 for his or her grade. But what do you think the 1 is? Very close. It's not how many assignments they didn't do. Very close. Very good. It's their attendance. So specifically, X represents what? Number of absences. Number of absences. See, I keep data on this kind of stuff. Now that you know that this is the number of absences every student had, and this is the grade that every student had, do you see a trend in the data? And if you do, could you make an argument for what's going on here? Anybody want to put together an argument? You're shaking your head. Give me an argument. What's going on here?
The less you miss class, the higher your grade is.
Do you guys agree with that? The less you miss class, the higher your grade is. Or vice versa. The more you miss class, the lower your grade is. And if you want to see the trend, we'll do this later. We're going to do this in an activity coming up. But if you want to play with this, do you guys see that the line tool? Perpendicular line, parallel line, you see that one? If you go on the drop-down menu, you can do what they call a best fit line. And I bet some of you did this in high school algebra, where you take a bunch of data and you try to get a line that fits it. If you go to the best fit line, and then just kind of click and hold and draw a box over all of your dots, like that, there's the trend line that goes right through the middle of all the data. So, does it have a negative trend? Of course it does. As absences increases, grade decreases. So actually this activity was twofold. I wanted you to be able to copy and paste a bunch of points into GeoGebra, and I'm preaching at you that you should come to class because it makes a difference. Right? Okay. Comments or questions on that? We comfortable? You can scrap this GeoGebra file if you want now. I'm just going to go File, New. Keep it if you want, whatever. I'm just going to have a new screen up there. I'm going to go back to my PowerPoint here. Okay. So, that was the practice data file. What I'm going to have you do is open up your textbook, your PDF textbook. You should have downloaded that. I'm going to have you look at numbers 11, 17. I'm going to write these down here. 11, 17, 23, and 39. These are homework problems from section 2.1. I think they're on page 125 of the textbook. So I'm going to go to the textbook so we can be there. Here's my textbook. Same textbook you have. Let's see what page I'm on here. Now when I say page number, I'm not referring to this page number. I'm referring to the page number that's actually on the page. I think they're on page 125. Go to page 125. Okay. There, I highlighted them on my screen. We're going to practice number 11, 17, 23, and 39, but I want you to do it on your computer, on your GeoGebra. So I'm going to go to number 11, and number 11 says, for each of the following exercises, solve the equation for y in terms of x. Okay? Now, you can do this on paper, right? If you wanted to do this on paper, it says we're supposed to solve for y. That means we're going to get y all by himself. Let me bump this up a little bit so it's a little bigger. We're going to get y all by himself. So if I understand a little bit of algebraic procedure, I'm going to say, well, you know what? I'm going to subtract 4x from both sides of the equation. So then I'm going to have 2y equals negative 4x plus 8. You guys okay with that? Simple 8th grade algebra there, right? And then if I want to get y all by himself, I'm going to divide both sides by 2. So I divide by 2, I divide by 2. Y equals negative 2x plus 4. Do you guys agree? Negative 2x plus 4. That's all the directions we're asking us to do. Okay, I want you to take that 4x plus 2y equals 8. Go to your GeoGebra and punch that in to your input bar at the very bottom of your GeoGebra. So if I open that up, options, I'm going to make my font size bigger so you guys can see it. In the input bar at the very bottom, I'm going to do 4x plus 2y equals 8. And I'm just going to hit enter. And it graphs the line for me. And notice how your computer spits it out. It spits it out as 2x plus y equals 4. What it did is it simplified it. It divided everything by 2. Right? So it's in 2x plus y equals 4 mode. But didn't our textbook homework problem say solve for y? So we're not done, right? The computer didn't quite do what I wanted it to do. I wanted the computer to get y all by himself. So what you can do is you go up to that equation there in your algebra window and right-click on it, and notice you can change the form. And you guys are familiar with y equals mx plus b. That's the standard slope-intercept form of a line. Just choose y equals mx plus b, and it'll change it for you. And now it says y equals negative 2x plus 4, and I believe that's what I got when I did it by hand, right? So what I'm trying to show you here is there's a lot of things that we do with paper and pencil that we can also do on our computer. And if you're comfortable doing it one way, go ahead and do it one way. If you're comfortable doing it this way, I'd like you to kind of have your brain in both worlds. Like, I can pull out my paper and pencil, or, you know what? My computer might help me get there a little bit faster. All right? Everybody got our graph? Not too bad? Let's go to the next one. Number 17 was another one from the homework that I picked out that we were going to look at. So I'm going to go to number 17 here. The directions for 17 say, for each of the following exercise, find the distance between the 2 points. Okay, here we go. Number 17 has the following 2 points. Negative 4, 1. And 3, negative 4. So I want you to plot those 2 points. And then I want to see who can figure out how far away those 2 points are. What's the distance between them? You might be able to do it with your paper and pencil. You might be able to do it with your computer. You might be able to do it both ways. But I'm curious to see who can do what here. Negative 4, 1. And 3, negative 4. So I'm just going to scrap this one again, do a new file. Font size. Negative 4, 1. 3, negative 4. Again, go ahead and get your screen so that you can easily see your 2 points. I'm going to zoom a little bit just to make it bigger for you guys. There's my 2 points. So what I'm interested in is the distance. I'm going to draw in a little line segment here. I'm going to draw a segment from here to here. I want to know the distance of that segment. If you were doing this on paper, anybody want to tell us how you'd do it? Rise over run? Is that going to give us the distance? What's rise over run going to give us? It's actually going to give us the slope. So we have these formulas, right? Slope formula. Slope formula. We have what we call a distance formula. We have what we call a midpoint formula. So right away, there's like 3 nuggets of information that some of you may have memorized all of these. Some of you may have heard of them, but you're like, oh, I can't remember which one's the slope formula and which one's the distance formula and which one's the midpoint formula. Does anybody ever feel that way? So what did my little poster say? If you haven't memorized those formulas, that's okay. Because we should just be able to logically figure them out instead of going straight to a formula and plug and chug. Okay? So, we don't necessarily just want the rise over run, although that is going to be involved here. Did anybody want to help them out? What can we do here? going to give you a hint. The point -4, -4, I'm going to plot it. This point is going to help me. Why? Point C that I just put up there.
Is it the middle point?
Kind of. I mean, the midpoint would actually be this point, right? The midpoint between the 2 points. We're going to do that in the next example. Do you guys agree that if I was just counting little boxes or counting grid marks, there's no way I could count all of these little grid marks and come up with an answer? Because it goes across the grid, right? It's not straight. Do you think I could count from here to here? Should be able to, right? This is a height of 1. Notice this is 1. So this is 1. This is the point -4, 1. And down here I'm at -4, -4. So if I counted the boxes, or if I just go from 1 to -4, how far away is 1 and -4? 5. It's a distance of 5, right? A straight up vertical distance is really easy to find. And a straight horizontal distance is really easy to find on a grid. The difficult distance to find is when it's at an angle. Do we agree there? But that's the one we're trying to find. So if this is 5, what's this one? Well, I'm going from -4 all the way over to +3. That's a distance of 7. If you know 7 and if you know 5, you should be able to figure out question mark. How do you do it?
5 squared plus 7 squared equals x.
Very good. It's what we call the Pythagorean theorem, right? A squared plus b squared equals c squared. You guys have solved right triangles before. This is a right angle. So you're exactly right. We're going to do 5 squared plus 7 squared. And that's going to equal question mark squared. That's what I'm trying to find, right? So 25 plus 49, last time I checked was, what, 84? 25 plus 4, oh, no, 74. So we know that 74 equals question mark squared. So what's my answer? Square root of 74 is my answer, right? So which of my 3 formulas did I just do? Did I find the slope of the line? Did I find the distance? Or did I find the midpoint? I found the distance, right? Now, some of you may have memorized this before. It looks something like this. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Anybody seen that one before? Maybe you've memorized it, maybe you haven't. All that is, the distance formula, is just the Pythagorean theorem, right? This distance right here was our 7. It's our horizontal distance. So this is like a squared plus, this is my vertical distance, b squared. And then we know that if we take the square root of both sides, that my distance c is going to be the square root of it. So the distance formula is nothing more than a complicated looking Pythagorean theorem is what it is, right? So when I preach memorization to you guys, I would say if you want to memorize that formula, go for it. But what's better than memorizing it is understanding where it comes from and how you can use it, right? So now I could do any 2 points that I wanted to. And you could draw yourself a little triangle, or you could count tick marks, and you could apply the Pythagorean theorem, and within a few seconds you could come up with that answer, right? Or I could just use my computer, and underneath the measurement tool here, it says distance. See that one? So distance or length. So I choose distance or length. I click on that segment that I drew, and it tells me that it's equal to 8.6. Well, if you pulled out your calculator, what did we say the answer was going to be? Square root of 74. If you punch in square root of 74, whoops, It's 8.602325267. So what's my computer doing? It's rounding. Here's another GeoGebra lesson for you. Underneath options, very first one, rounding. See that one? What happens if I went all the way to 10 decimal places? See what it's doing for me now? Now it's spitting out the same thing that my TI calculator spits out with 10 decimal places. So the GeoGebra isn't going to give you the answer in root form. It's going to give you the decimal approximation of it. So if you look at your textbook, you should be able to do number 18, number 19, number 20. Those are good ones for you to practice, right? Let me jump down to number 23. 23 gives us 2 points again, but this time they say find the midpoint of those 2 points. So go ahead and plot them. -1, 1, 7, and -4. Give myself a new, fresh screen here. -1, 1. Whoops, I got to put it parentheses. And the other one was 7, -4. So I've plotted my 2 points. This time it says don't find the distance between the 2 points. It said find the midpoint. Well, again, there's a formula for that. It's called the midpoint formula. Can you guys, just with your eyeballs, guesstimate where the midpoint's going to be? Probably about right, I don't know, there. You guys, did it get it kind of close anyways? So how would I figure it out on paper? This is -1, 1. This is 7, -4. Do you guys agree that this is going to have some x comma y, right? We just don't know what x is and what y is yet. Do you guys agree that that x value is going to be exactly halfway in between -1 and +7? How do you find a number that's halfway in between two numbers? It's the average of those two numbers, right? How do you find the average of two numbers? Add them together, divide by 2. So if I add -1 and 7 together, I get 6. If I divide by 2, I get 3. Well, the y, the height of it, is going to be halfway in between +1 and -4. Take +1 and -4, add them together, I get -3. -3 divided by 2 is -1.5. So I should be at 3 -1.5. My black dot, I didn't eyeball it very well, did I? So if it's going to be 3 -1.5, that's how you can do it on paper. There's something called the midpoint formula. This guy right here, midpoint formula. It says, take your x1 and your x2, add them together and divide by 2, comma. Take your y1 and your y2, add them together and divide by 2, comma. Again, it looks like this intimidating, ugly, awful formula when you look at it. But if you just think of it as like, I can average two numbers, add them together and divide by 2, that's not difficult. So again, you can memorize the formula, or you can just think about it and what it means. Or you go to your computer, and underneath one of these guys, it'll say, where am I at? Midpoint. Go to your new point tool. See that one? Midpoint or center. I'm going to click on midpoint. And now I got to click on my 2 points. So I'm going to click on point A. Then I'm going to click on point B. And my computer spits it out. And what's the coordinates of point C? It is 3, -1.5. The same thing I did when I calculated it on paper, right? Okay, we're going to keep moving. I'm not going to lecture at you like this on a lot of days. I just want you to get used to what we're going to do, and more often than not, I'm going to turn you loose on a project or turn you loose on something, walk around the room and see how everybody's going. The last one I wanted to look at here was number 39. It says, for each of the following exercises, plot the x and y intercepts, and then graph a straight line based on those 2 points. If I wanted to do it by hand, I plug in a 0 for x, solve for y, that's my y-intercept. If I want to find my x-intercept, I plug in 0 for y, solve for x, that's my intercept. I can do it on paper, or I can just type in x minus 2y equals 8. I'll go to my screen here, x minus 2y equals 8. X minus 2y equals 8. And now I can just use my eyeballs. My x-intercept is the point 8, 0. My y-intercept is the point 0, negative 4. There, I'm done. Right? Pencil and paper, computer. Thinking about it both ways. Okay. So, what did I want to get out of section 2.1? A lot of this is massive review for you guys. Some of you are sitting here like, I thought this was college algebra, not 8th grade algebra, because this is stuff that you did in 8th and 9th grade, but this is good review. Okay? So, what have we talked about here? Plotting points, graphing lines, intercepts, distance formula, midpoints. That's what I want you to practice both on pencil and paper and on your computer as you practice some of your optional 2.1 homework. Remember, the practice homework is optional. I'm not going to have you hand it in. So if you think this is easy and you don't need any practice, then don't waste your time with it, right? But what is not optional is your 2.1 quiz, because I give you a grade on that, right? So based on what we've kind of practiced today and what you practice on your own, you should be ready to take that 2.1 quiz. When you take that 2.1 quiz and you do terrible on it and you get 1 out of 5, what are you going to do? Take it again until you get a better grade, right? Now, I think I told you this on Wednesday, but when you take a quiz and it spits out a grade, I specifically set it up so that the computer does not tell you which ones you got right and which ones you got wrong, which is going to frustrate you. Okay? Because if it tells you which ones you got right and which ones you got wrong, then without even reading the question, you can just guess, click. Oh, 2 out of 5. Guess, click. 3 out of 5. Guess. You can do the quiz without even reading the questions. Why do I give you these quizzes? For your own good, for your own practice, to prep you for the test so that you can learn. So if you're doing like 17 attempts at a quiz, that tells me you're not even reading the question. That you're just going through and taking advantage of the unlimited attempts. I would rather you actually try to figure out why did I get one wrong and which one did I get wrong, and I'm going to go back and I'm going to figure it out. I'm going to do what standard number 1 says. I'm going to persevere in solving a problem. I'm going to try to find my mistake. Okay? So that's part of what I want you to do for next time, but don't go anywhere yet. I want us to practice something else really quick. So for next time, it says assign for next time the 2.1 quiz. That's the 5-point quiz. And then the practice homework, which is optional, if you want to practice it. Okay, what I do want to do before we leave here today is I want you to quickly practice. I'm going to give you a little preview of our next section. This is what we're going to do on Monday. I want to see how good some of you are. So here are 4 equations from section 2.2. Pull out a pencil and a scratch paper. We're not going to do this on computer. I want to see if you can do this scratch paper. Go ahead and see if you can solve any of these 4. Work on whatever one you want. We've got 5 minutes for you to figure out what you can figure out here.
All these names didn't have any links to their folders there. So like these 2 didn't do them, but all these other ones I couldn't get access to.
Couldn't even find the folder?
No, couldn't find them, so I don't think I'm shared to them. Or
We'll have to check it out. Okay. My hunch is that you're going to have an easier time with the 2 at the top and a more difficult time with the 2 at the bottom. That's my guess. These 4 items on the PowerPoint right now, they are from the Try It exercises in section 2.2. They're right out of your textbook. So the way your textbook works is it'll give you an example of something like solve this equation, and then it'll show you how to solve it, show you all the steps, blah, 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 and then right underneath that, they'll have one called Try It, with no solution provided whatsoever. It's kind of like, okay, we showed you how to do it, now here's one for you to try on your own. That's what these 4 are from in section 2.2. I bet most of you did this for the first one. Did I do it right?
You're the teacher.
I'm the teacher? Teachers make mistakes. It's one thing I can guarantee is going to happen. Although I did just have 2 mellow yellows, so I should be in good shape. Are we cool with the first one? I hope we didn't struggle with the first one. That's about as elementary as it gets as far as algebraic solving goes. What makes the second one a little bit more difficult? Yeah, multiple x's. We're going to have to gather like terms. We're going to have to use what we call the distributive property, right? If I were solving this guy, I would go like this: negative 6x plus 2 plus x equals 14 minus x. Then I would gather these like terms, and I'd say negative 5x plus 2 equals 14 minus x. Then I'd gather like terms again. Maybe I add x to both sides. So I'd say negative 4x plus 2 equals 14. And I'd move the 2 over to the other side. Negative 4x equals 12. X equals negative 3. Anybody with me? A little more difficult, but again, something that you should be able to handle. And we are out of time. So what I'd like you to do, does everybody have the bottom 2 written down? See if you can come up with something. Because when we start on Monday, first of all, you'll have a bell work assignment, just like you always do. One of the first things we'll do is we'll talk about those 2 equations. And then we'll dive into a little bit more on section 2.2, and we'll get going from there. Everybody know what their assignment is for Monday? 2.1 quiz. Now, if you didn't do the syllabus quiz, you're already behind. So you should do that. If you didn't post your GeoGebra exploration file to your shared folder, then you're already behind. Now, Mr. Rambo just indicated to me that at least 3 or 4 of you don't have your file in there. And several of you didn't even share your folder with Oren. So you may have just shared it with me, but not Oren. Remember, you were going to share it with both of us, right? So if you're one of the culprits that we can't find your GeoGebra file, look into that. Have a great weekend. See you on Monday.